Welcome to part 2 of our 4-part series on reinforced concrete diaphragms. In our last session, we went over some of the typical types of in-plane forces that you would expect to see when designing concrete diaphragms. So we discussed wind loads, we discussed seismic loads, and then some other typical loads as well. So now that we have those, what we would like to do is to take those loads, model our diaphragm depending on its relative stiffness, and then allocate those horizontal loads to the vertical elements of the lateral force resisting system. Now certainly we have computer programs that do that for us, and I think the analysis methods and the beam models we're going to introduce today will help us understand a little bit more, especially how the forces flow through the diaphragm to those lateral force resisting elements, so we can understand the output from the software a little bit better. And it's also going to help us to see exactly where the reinforcement should go. So that's our goal here today. We'll start by talking about stiffness modeling, then get into horizontal force allocation, and then we'll do the simplified methods, and you'll see, and especially in the 4th session where we do some comparisons between that and ETABS, you know, if you have certain types of structures that are fairly regular, they don't have to be, you know, your typical square box, but a fairly regular structure, the analysis methods we're going to present today put you right there in terms of what you would get from ETABS. So let's go ahead and get started. Like last time, all of the sections, figures, etc. that we reference from ACI will be coming from the 2019 edition, chapters 12 and primarily section 1812 for our seismic as well. Any references to ASCE 7 will be from the 2022 edition. All right, let's begin by in-plane stiffness modeling. If you look at section 12423 in ACI, they list 3 different types of diaphragms. They're rigid, flexible, and semi-rigid. We're going to go over some very general definitions and then some specific definitions on how we can determine exactly what type of in-plane stiffness we have for our particular diaphragm. Now, we are talking about reinforced concrete. More often than not, it will be a rigid diaphragm. However, there are cases where that may not be the case, and we want to make sure we understand, you know, to distinguish between what's rigid, what's flexible, and where we should be using, say, for example, a semi-rigid diaphragm. So we'll start with the rigid diaphragm, and this graphic here sort of shows you exactly what we're trying to achieve with this diaphragm. In general, the in-plane deflection of the diaphragm itself is going to be relatively small compared to that of the overall vertical elements of the lateral force resisting system. So you can see with a nice reinforced concrete 8-inch reinforced concrete slab, it's going to be fairly difficult for that slab, you know, to deflect in its own plane due to the lateral forces. But the walls and the moment frames that may be connected to it can easily deflect. So that would certainly be a general definition of a rigid diaphragm.